Looking at number 4, right, a fluorine gas of 300 Kelvin occupies a volume of 500 milliliters. So that's our first T1 and V1. Right, and then to what temperature, so here's our question, to what temperature should it be lowered to bring the volume to 300? So now we know we're looking for T2 if the volume changes to 300. Remember, you don't have to write down those givens, I just suggested. You do have to write down the equation. Right, I've got volumes and temperatures, so I'm using Charles's law. Sorry about that bell there. Now I'm going to plug in my numbers, right? So I'm going to look at it and say, well, this is T1 and this is V1, right? So I'm going to plug those into the equation. This is V2, so I'm going to plug it into the equation. Now I've got to solve for T2 because it's on the bottom of a fraction. I need to cross multiply. Right, so 300 times 300 is my first cross multiply, and then 500 times T2. Now I need to isolate T2, so I'm going to divide both sides by 500. And looking at my numbers, 300, 300, and 500 all happen to have 3 sig figs, so I get my answer to 3 sig figs, and because it comes out to be 180, I need to add that decimal in there to make sure that my 180, that 0 is significant. Moving on to number 7. Right, oxygen gas is a temperature at 40 degrees Celsius when occupies 2.3 liters. So I know that 40 and 2.3 are our starting position, and we want to know what temperature in Celsius should it be raised to occupy 6.5 liters. Well, here's where students tend to make a mistake. The temperature that they give you is in degrees Celsius, and they're asking for you to solve for degrees Celsius, which is the same unit, and so students won't convert. But you have to convert your Celsius to Kelvin no matter what. It has to be converted. Right, so 40 plus 273 gives me that answer in Kelvin. Now, in my equation, I know that this is T1. Right, I have T1 and I have V1, and now I can go through and plug in all my numbers. Again, cross multiply, right? So 313 times 6.5, and then that leaves me with 2.3 and T2. So I can solve now for T2 by doing 313 times 6.5 divided by 2.3. Now that gives me my answer in Kelvin, and notice that this is 2 sig figs, 2 sig figs, 2 sig figs. So what I did here is I went to 4 sig figs because I need to still convert back to Celsius. So my final step is to convert it back to Celsius. Because my answer is in Kelvin, it goes over here in my equation, right? Because Kelvin is on the left-hand side. So 884.6 minus 273, and then I round to 2 sig figs. Notice there's no decimal place there, because if I did, that would make that 0 significant.